1, same, it's a 0. Make sense?
Mm-hmm.
Yeah.
For your next one, it's going to be the not of Q XOR of X, so that means whenever we look at same, it's on, correct?
Yes.
Okay.
Yeah. Because the not of here, a single not in XOR negates the XOR that's going in, which means it checks for sameness. So all I'm checking to see is X and the state bit the same. Now, I don't actually have to do any more work because I already have something that tells when they're different. So same is the opposite of different, isn't it? So all I have to do is walk down here, and K should be the exact opposite of J. So wherever the J1 is a 1, I put a 0. Whenever it's a 0, it's a 1. Recognizing that saved me an awful lot of writing, didn't it? Now think about what that does. It's always a 1 or a 2. That's the inputs, the JK, right? JK is either 0, 1, a 1, or it's 1, 0, a 2. Which means I'm right here in the middle. What did I turn that first flip-flop into? It's a D flip-flop. No, we took the middle ones right here, right? It's a D flip-flop on whatever's coming in on your J line. Yeah. Just an interesting note. And if you notice, for our state 1, it's identical to J1, because that's what we said. It's a D flip-flop on whatever's coming in J. Right? If you recognize that, D flip-flop, it's either gets a 0 or a 1. That's exactly the same as J is. That just means I can copy J1 into my state 1. Do we all agree? Down? Okay. So watch. J1 and K1, they're always different, aren't they? So look over in the table. When are J and K different? Only here in the middle. So you are here. Huh? And what it's saying is your next state is exactly equal to whatever J is. If your J is a 0, your next state is a 0. If your J is a 1, your next state is a 1. Does it matter what Q is? No. Utterly irrelevant. Matter what Y is? Does it matter whatever this wire is? Utterly irrelevant, isn't it? Whatever is on the J line coming into it is what the next state is. That's what the table tells us. Just follow it. Because that is our characteristic. That's how that flip-flop functions. And we have wired it up to take whatever is J and store it. Fair? Okay. So what that means is my next, we're talking about state 1, because this is flip-flop 1. So whatever's on J1, whatever's on this line, which is this column, is the next state. And you can already see when we went through kind of by hand without recognizing this, we came up with that. 0 gave us a 0. A 1 gave us a 1. But we now know from looking at how the table is formed up, it's got to do that. Because of the way I wired up these exclusive ORs, one of them taking Q, the other taking Q prime, with the other wire both being X, forces it to behave that way. Fair, yes? Good. All right, so once we know that, now we can come in and say, great, I now know what's exactly going on here. I will just copy my J1 right into my state 1. So it's 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. If you recognize how the gates function, it will go faster for you when you're doing the circuit. If you look at this and you go, oh my God, I would never figure that out, then don't worry about it. Take the state bits and write them in and follow them through the circuit. It will work. It's not wrong, it's just slower. But if it's the way you will get the right answer, I would rather take twice as long and get the right answer than go really fast and get it incorrect. Yeah.
It looks like K works the same way. Is that?
For which one?
For the first flip-flop. The K values in your state two. Oh, that's
Well, K1 is going to be the exact opposite. I mean, it could have done the same thing. But J1 and K1
He's on
were
that
used.
K2.
state, your first flip-flop, it's Q1, or is it S2? Next
Well,
state.
this, I'm calling the output of this one, I'm calling this S1, and I'm calling this one S2.
Okay. The Q1 though, and the first flip-flop,
Yeah,
Well, what
which
is
is,
that?
Q1 is state 1.
do you need to know the output of that one?
That's
That
Q
one.
prime.
Yeah.
So just whatever it is.
That's, you don't even need to have that in the table, or?
Well, why? Q prime is always the opposite.
Right, okay.
I mean, I could, it'd be really boring looking. The reason why we do this and I use this is because flip-flops, remember, always have both states. They always, always, always have them. That's how we built them. Remember we took the two NOR gates and fed them back into each other? And the output of one NOR gate gave us Q and the output of the other gave us Q prime? And that's how we built them. We took two NOR gates and just hooked them up circular style. And they feed their signal back into each other. So, I mean, all I have to do is which wire do I run out? Do I run out the wire from one flip-flop in which I get, you know, Q, I run out the other one, I get Q prime. I run them both out, I get both Q and Q prime. So if I'm gonna use Q and Q prime, which in this case I was going to use, it's easier to run them out from the actual circuit than put in an extra inverter to make a signal I already have.
Q prime's not used. Then. So
I mean, Q
Y,
prime's used right there.
but it just feeds back on itself. It has nothing to do with Y, is what I'm saying.
Well, I mean, it's the opposite of one of the signals going in.
Right.
I mean, so,
But it's
I mean, I
a
guess
wire.
it depends. I mean, there's no wire going from Q prime to Y, if that's what you mean.
Yeah, it just.
I mean, but internally realize Q and Q prime are hooked together. They're negations of each other. So there is a relation there, but if you're saying does Q prime directly wire to here in what I've shown, no. Internal to this circuit, there is a hook though. Realize inside this, I actually have those NOR gates feeding into each other. Huh? So I've got Q and Q prime. So they're not separated from each other because Q prime goes into Q and Q goes into Q prime. That's how we were getting memory, is their signals coming through, and these are both powered, so they maintain the state by their power.
Can you show an example how to find the next state when I would put the numbers in the circuit?
Yes, why don't we do, we have one thing left, which is K2. Why don't I do the K2s all by doing the numbers in the circuit? So I showed you how I could use the equations of the ones to get Y and state 2, or sorry, state 1, and the appropriate J's and K's for them. We'll do K2 then, this one, entirely by just writing this numbers in there and calculate it. Realize you can do either way. I don't care. Take what you're comfy with. We good?
One question. An earlier comment, K does affect Y, but not directly, right? Or, I mean, Q prime. So your S.
Well,
your Q
that's what I'm
prime
saying.
does
I mean,
affect
Q
your
prime
Y.
affects Y, but
Yeah,
through
not
the
in-
circuit.
Exactly.
You know, I mean, it affects it because this is Q prime, and this is Q, and Q's going out
Yeah.
to there. So, I mean, in a sense, it does. But my comment is it's affecting it inside the component,
Okay.
not on the external wire.